Imagine stepping out into a freezing winter storm. You are wearing a premium, expensive down jacket, but there is one problem. It is completely unzipped. That scenario sounds ridiculous, but it is the standard way we build most homes. We pack thick insulation inside the walls, which acts like the down jacket, but we leave the bare wooden frame exposed to the cold outside air, which works exactly like that open zipper. This diagram shows a flat view of a standard wooden house frame. Watch what happens when we highlight the wooden skeleton, or the studs. Those vertical beams add up fast, making up 25% of your total wall surface. That means a full quarter of your house has no insulation at all. The reason this matters is that wood is a poor insulator. It offers very little resistance to the cold when you compare it to the thick insulation packed right next to it. This top-down view of a wall shows exactly how heat escapes through a process called thermal bridging. Heat inside your home acts like traffic. When it hits the insulation, it stops. But when it finds the bare wooden studs, it bypasses the jam and speeds straight down those wooden highways directly to the cold outside. Because of these constant thermal bridges, a standard cold climate house is leaking your heat every single hour of the day. You are paying to keep your family warm, but that heat is slipping right through the wood and into the winter air. To solve this, we use something called continuous insulation. Instead of only putting insulation between the wooden studs, you wrap an unbroken blanket around the entire exterior of the house. You are finally zipping up the jacket and adding a heavy windbreaker over the top. This comparison matrix shows the two main choices for that outer blanket. You have rigid foam on one side and stone wool on the other. Foam provides a high insulation value, but it can trap moisture and has a high melting hazard. That brings us to stone wool, like the Rockwool comfort board. Because it is made of spun basalt rock, it resists fire up to 1100 degrees Celsius, and insects hate the texture of it. This breathability is its most valuable feature. It ensures that any water vapor inside your house can pass through the wall rather than getting trapped. By keeping the wood dry, you stop the growth of mold before it can ever start. Keeping the entire wooden skeleton wrapped, warm, and dry from the outside is the most significant thermal upgrade you can make for an energy-efficient home. Now that the house is wrapped in a soft blanket of insulation, we have to find a way to attach heavy exterior siding without crushing that blanket. Take a look at this 3D cutaway of an exterior wall. We solve the attachment issue by placing vertical strips of wood, called furring strips, flat against the outside of the insulation. These strips act as a solid anchor point for your siding. To hold those strips up, we use extra long structural screws. As you see here, the screw drives through the furring strip, through the thick insulation, and bites deep into the house's original wooden frame, pinning everything tightly together. When we attach the siding to those vertical strips, we create a hidden benefit. Notice the gap between the siding and the insulation. This is a 3/4 inch empty airspace, known as a rain screen gap. This space allows any rain that sneaks behind your siding to drain away, while fresh air circulates to keep the layers of your wall dry. This installation provides a drainage path and constant airflow, protecting the wood from the moisture that leads to rot. It keeps the structure of the house stable and dry for decades. A continuous insulation system is only effective if it is installed correctly. If you are building or renovating, there are 3 red flags to watch for on the job site. This view shows red flag number 1, the gap fail. All of your insulation boards must be tightly butted together. Any small gaps left between them act as mini chimneys where your heat will rapidly escape. Red flag number 2 is the placement of the weather wrap. The protective house wrap must go underneath the insulation, tight against the wood. If your builder puts the wrap over the top of the insulation, they cannot properly air seal the house. Finally, red flag number 3, uninvited guests. Mice and bees will view that empty rain screen gap we created behind the siding as a perfect place to build a nest. This close-up shows the fix. At the bottom edge of those wooden strips, there must be a corrugated insect screen. Air flows up through the screen to dry the wall layers, but pests are blocked. To make sure your project is on the right track, ask your builder this. How are you handling the insect screen at the base of the rain screen, and what specific screw spacing are you using for the furring strips? If your builder says they don't use screens, or claims they use standard deck screws to hold up the furring strips, you should push back. Deck screws are not strong enough and can snap under the weight of the siding. Wrapping your home perfectly creates a draft-free, mold-free, and incredibly comfortable space for your family. If this helped you understand the secret to a warm, healthy home, please like this video and subscribe to the channel for more building breakdowns.